So for the experiment of generation of these diagrams like inverter, AND gate, OR gate, or NAND gate, or NOR gate, so the steps are: first go to activities, go to terminal, then you have to enter CSH, then source /home /install start like /cshrc, then click on enter. Then this welcome to Cadence tool comes. In this you have to give virtuoso, VIRTUOSO, then click on enter. Okay, a pop-up opens. So just maximize this pop-up. So in this, go to file, in file go to new, in this library. So I'll just do a simple NAND gate. So I'll just give the name as NAND underscore GAT is enough. Okay, then you have to click on attach to an existing technology or library. Click on this, then click on apply. Okay, then just click apply by selecting GPDK 180. Click on apply, then click on OK. Then after that, again here we have to click on apply, then click on OK. Okay, then go to file, again come to new, then come to cell view. So here again I'll just give that name NAND. Here you can give any name, it doesn't matter. Gate I'll just give. Okay, then I'll just give on OK. So this schematic view opens. So in this we have to draw a circuit. So first on the keyboard, first we'll click I. When I clicked I, this add instance opens up. Okay, so in this add instance, click on browse. So another pop-up opens up. So in this browse, you have to go to GPDK 180 and just go to Cmos. Like, then symbol you have to click, symbol, this one. Then you come here, you have to click on hide. So for NAND gate we need 2 Cmos. So I'll just keep 2 Cmos in series. Then again after placing this, again I'll click I on the keyboard. Again I'll go to browse. Then I'll come here. Then instead of now Cmos, I'll put PMOS. We need 2 PMOS. So again symbol. Then I'll come here. I'll click on hide. So I'll just click over here. One PMOS. Another PMOS. I'll just click once R. One more time R. R stands for rotate. Only R is enough. Nothing like control R or something. And I'll just place it over here. Okay. We have kept 2 Cmos, 2 PMOS. Again I'll click on I. I'll go to browse. So in browse, after PMOS and Cmos is done, we have to give the voltages. So for that you have to come to analog library, analog LIB. Okay. In this you have to select 3 grounds by default, G and D. Ground in the symbol. Then again come this side, click on hide. Then keep 1 ground this side, 1 ground at the bottom, 1 ground on the right hand side. Okay, 3 grounds are done. After ground is done, again I'll click on I. Now we need to have a voltage source. So that is VDC. So I got a VDC, it's in symbol directly. So I'll just click on hide. This voltage should be above PMOS. I'll just give rotate and I'll place it above this PMOS. Okay, 1 voltage source is enough. Then again I'll click on I. I'll give browse. After voltage source, now I'll give V pulse. In V pulse, yeah, after selecting V pulse, no, see always voltage 0 is 0, voltage 1 is 1.8 volt you have to give. That is the maximum thing. So just give V2 as 1.8 volt. Then after that you have to give rise time and fall time as 100 picoseconds, as well as fall time is 100 picoseconds. Okay, then after that you have to give pulse width, let's say here I'll give 10 nanosecond pulse width, then period should be given as double of pulse width. So I'll be giving here 20 nanosecond. Okay, then all these things are full, that's it. Then I'll click on hide. So I'll keep this one over here. Okay, this is like an input A. So I need to place one more input B. Let this be here for time being. I'll click on escape and I'll just change the settings of this by selecting that, and I'll click Q for Queen on keyboard. Then in this, just change the pulse width. Instead of 10 pulse width, I'll give 5. Delete 5. Okay, and even time period, instead of, I told you it should be double of this 5. So this one is going to be 10 now. 10 nanosecond. Click on apply, then OK. So this is set now. So we have kept all the components, I hope so. Then now wiring is left. Yeah. So now click on W on the keyboard for wire. Okay. See this positive point of the PMOS connected to the voltage source, positive thing. Similarly, this point of the PMOS connected to the voltage source, which is in the positive terminal. Okay. Then similarly, even this point you get it over here and connect it to the positive terminal, as well as this center thing of the PMOS connected to the same positive terminal. Okay. Then after this one is done, we have to go into the bottom, that is the NMOS thing. So from here I'll connect both the PMOS together. So this NMOS gets connected to this point. I'll zoom out again. Over here we need to zoom in. So the bottom NMOS gets connected over here. If you click on this button, no, this is zoom to fit it. Okay, it will automatically come like this. So again I'll go down. So from this point of the PMOS, see, I haven't selected that point correctly. Escape, again W. Click on this point, will come down, connected to this point of the ground. So the center point of the NMOS is there, no, get it separately, connect this one along with the ground. Similarly, this one will come to the ground point of the wire. Okay, so NMOS and PMOS basic circuiting is done. Then all the negative terminals, so I just made the connections for all these things. Okay, make sure that all the tips are connected properly, because when you zoom in only, you will be getting to know if any wire is not connected at any junction terminals. Okay, then you have to go to launch. In launch, the very first option you have to select ADEL. After clicking on that, a pop-up appears. So in this pop-up, click on analysis, then click on choose. It should be in transient. Stop time should be 200 nanoseconds. Then click on moderate. Click on apply. Then click on OK. So after this is done, you have to go to outputs. In outputs, click on to be plotted. In this, select on design. So before we select on design, we have to give 3 things. See, this is A, this is B, I have assumed, and we have to take the output over here. No, so for that you have to click on the keyboard P. When I click P, a create pen appears. So I'll give V small a. This is an input, so we don't need to change anything over here. Click on hide and I'll place it here. I have assumed this one as A. Again click on P. This is the input B. V suffix B I'll give. Then I'll hide this. I'll just place it over here. This is V suffix B. Then again, now we need to see the output waveform. No, so this one is, I'll give it as VOUT, V out, and in this drop down box select output. Then click on hide. We'll be taking the output over here in between the NMOS and PMOS. So just place it over here. After placing this, we'll just click on escape once, then click on wire. Join this point to the V out, as well as come on top. The VA should be connected along with the V1's output, the pulse generated at V1. Similarly, come at the bottom, click on VB, come to the pulse generated by V2, select over there. So these are the terminals you have to select properly for the inputs and for the output. So after making up the circuit, this is for a NAND gate, then you have to click on launch, go to ADEL, click on analysis, click on choose. It should be in trans, then give it as 200 nanosecond, click on moderate, then after that click on apply, then click OK. After this you have to go to outputs, to be plotted, select on design, select VA as the input, VB as the another input, and V out, which is our output. Then go to activities, come to the same schematic pop-up box, tick mark the save button, then click on this play button. You'll be getting the schematic waveform. After making this waveform in maximize, then you have to click on split current strip. Just click on that. So you'll be getting this our input VA, VB and V out. With the waveforms, you are supposed to verify whether the output is correct first. Okay, if it is correct, then you can proceed. So this is correct. Then you have to minimize this for seeing the rise time, fall time and propagation delay calculation. So what you can do is, when you're taking outputs or reading, just right click, go to style, click on solid. Similarly in this one also you can keep it in solid, in style, solid. Even on the bottom thing, right click, style, solid. So go to marker, create marker, come to vertical, just click on OK. Since we set at 1.8 volt, one value should be at 1.44 volt. So see, I came around 1.45, 1.43 as an approx. This one, V out, okay, this is 1.45. Then take one more marker, create marker, click on OK, come to 0.36, okay, 0.36 is 20% and 1.44 is 80% value. So somewhere around over here, 3.54 I just came as an approx. Then click Control on your keyboard and click this one also. So you'll be getting both the time periods, the time at this value. Just subtract this one minus this one. See, now this is falling, V out. So this is fall time. This difference is called fall time. Similarly, with the help of marker, click on this V out. You will know where the wave is falling. Let's say approximately over here, my wave is falling down. I'll zoom it out to this particular point. See, here my wave is falling. Similarly, come at 1.4 with the help of a cursor or the marker, create marker, come here to 1.4. Similarly, 360 millivolt. Then with the help of those timing values, subtract the difference. So with these differences, you'll be getting the fall time. The wave is falling down. So this is fall time. So when you get the thing, no, this one value will be in nanosecond, one more value will be in picosecond. Don't go wrong in the calculation. Take the average of these values, you'll be getting the propagation delay. So this is one step. Okay, after this, you may be asked to do one more thing, TDR or TDL. Okay, so for that, what you have to do is, in this, again come to marker, create marker, come to horizontal. In this, voltage is there, no? What is the maximum voltage we kept? 1.8 volt. Keep it as 0.9, half of 1.8 value. Okay, for one thing, V out. Click on apply, then click on OK. Similarly, you can take anything. VA will take as an example, or VB also you can select. It doesn't matter. Click on marker, create marker, keep it as 0.9 volt. Okay, click on apply, click on OK. So again, in the rising values of both the things, you have to zoom in. So here it's at 50 picoseconds. So similarly, click on this one and click on control. So you will be getting to know where is the 50% for this one. This one is for 50 and this one is like 96. So you have to calculate the difference for these things. Similarly, at the falling time, So when you calculate this, you'll be getting TDR and TDL. That's not a very necessary thing, but just for knowledge, you need to know that. Okay, so this is the complete thing. All the schematic diagrams like NOR gate, NAND gate, OR gate and AND gate is a similar process.